Hola, this is Liam in for Bear. Anthropic says Claude's text carries a watermark. I cloned the reference implementation for this whole family of techniques. Can you walk me through what the mark actually is? The watermark is a statistical bias, not an inscription. At generation, half the vocabulary gets a 2-logit boost at every token position. At detection, a z-test asks whether too many boosted tokens appeared by chance. The algorithm is 282 lines. The surrounding apparatus is 344,000 lines of file. The detection returns a p-value. A p-value is not a verdict. The word watermark comes from images, where there is a thing in the file you could point at. There is no such thing in the text. Nothing here is embedded. The repository JW Kirchenbauer/LM watermarking. Official implementation of the 2023 EICML paper by Kirchenbauer and colleagues. 16 commits since the first push. Built on the Hugging Face Transformer's logits processor abstraction, the hook that intercepts probability distributions before sampling. Logits processor matters. It doesn't reach inside the model. It sits between the model's output distribution and the sampling step, and it adjusts logits. The model's weights are unchanged. The watermark lives in the selection rule, which token the sampler picks, not in any parameter. Now the shape of the code. 7 Python files at the root, demo watermark. Pi is the CLI runner at 701 lines, watermark processor. Pi is 282 lines, the mechanism, extended watermark processor. Pi is 625 lines, more on that one shortly. Then normalizers, alternative seeding schemes, the spaces app. 4 subdirectories. Watermark reliability release has 252, 512 lines of file, experiment pipelines, evaluation JSON. HF Hub Space Demo has 44, 191. Homoglyph Data has 42, 351, 4 Unicode lookup tables. The number is large. The claim is about files, not source. The ratio. 2,317 root source lines. 344,000 lines of file across the 4 subdirectories, but most of that is Unicode lookup tables and experiment JSON, not source. Watermark processor. Pi is 282 lines. That is 12% of the root and less than 1/10 of the tree. The idea is 282 lines. Everything around it is apparatus. Now what calls what? The import graph app Pi imports demo watermark. Demo watermark imports watermark processor, the mechanism. Watermark processor imports normalizers. Normalizers imports homoglyphs. 4 files in the full repo import watermark processor, the demo runner, the Hugging Face demo, and 2 files in the reliability release. Watermark processor. Pi, 282 lines, 4 importers. Every call that matters routes through this file. If you want to understand what this algorithm does in code, that is the file. And then there is extended watermark processor, Pi. 625 lines, the README calls it recommended, and not one file in this repository imports it. One more finding, 3 copies of watermark processor, Pi in the tree, root, 282 lines, Hugging Face demo copy, 280 lines, 32 differing lines, reliability release copy, 672 lines, 592 differing lines, 3 divergent branches, none of them connected to each other. The Git log. 16 commits across 3 years. 2023, 12, the initial push, the paper release, the extended implementation, a Jonas Japing documentation pass. 2024, 2. 2025, 2, the most recent in September, a Hugging Face Spaces demo update. Every year has at least 1 commit. 16 commits is a paper artifact being maintained. This family of techniques is deployed at production scale. The reference implementation has 16 commits. That is not a project with dedicated resources. That is a researcher keeping the lights on. Time to read the code. 5 parameters, gamma 0, 5, half the vocabulary is green at each position. Delta 2, 0, the logit boost applied to green tokens. Hash key 50,485,863, the secret described in the code is just a large prime. Seeding scheme, simple 1, the RNG seeds on the single previous token only. Z threshold 4, 0, the detector's decision boundary. 3 functions. First, how the key and the previous token seed a fresh random partition of the vocabulary at every position. Animate how the green list is built at each token. At every token position, the mechanism draws a fresh random permutation of the full vocabulary, seeded by the secret key in the previous token. The first half of that permutation is the green list. It changes completely at the next position. It is never stored. There is no green list file anywhere in this repository. The seeding and partitioning code. Line 63, the previous token times hash key seeds the RNG, that is the entire secret. Line 74, torch, ranperm shuffles the full vocabulary using that RNG. Line 76, the first gamma fraction of the shuffle is the green list. Range shortened to L6280, L61, the assert overflows the frame at the type floor, see build log, MD. The green list is not stored anywhere. It's regenerated from scratch at every token, from the secret key times the previous token. Delete the key and it is unrecoverable. Now show the bias high entropy versus low entropy. When the model is uncertain, high entropy, multiple near-equal options, adding 2, 0 to the green logits shifts which token is sampled, choice flips. When the model is confident, Barack followed by Obama, the top token wins regardless of the green boost. The watermark is invisible at low entropy. It only bites when there's a real choice. Line 95, scores on the green list get plus green list bias, which is delta, which is 2, 0. That is the entire marking mechanism. Everything else in call is batch handling, RNG setup, and the calls to the seeding and masking functions. Scores greenlist mask equals scores greenlist mask plus greenlist bias. That is the watermark, one line, add 2 to half the logits. Now the test, 200 tokens versus 40. Detection is a hypothesis test. Under the null, no watermark, approximately gamma times t tokens fall green by chance. The z-statistic measures how many standard deviations above chance the observed count sits. At 200 tokens, the test has power. A watermark text clears the z-threshold of 4, 0. At 40 tokens, the distribution is wide and the same observed count does not clear the threshold. The test returns a p-value, not a ruling. Lines 153-163. The z-score, observed green count minus expected, divided by the binomial standard deviation. The p-value, SIPE, stats, norm, SF, the survival function, one-tailed area above z. This function returns a float. The threshold comparison happens in the caller. Detection is SIPE, stats, norm, SFZ. It returns a p-value. A p-value is not a verdict, and asking to see the watermark is like asking to see the loadedness of a single die roll. 1 commit. Commit BBE1FB8, August 2023. Message, documentation updates, the stat for watermark processor. Pi, 17 lines added, 15 removed. Most of it is genuine cosmetics, blank lines, PP8 comment spacing. But one line is not documentation. Buried in the watermark detector in its signature, the default value of ignore repeated bigrams changed from false to true. That is not documentation. 17 lines added, 15 removed, message documentation updates. One of them flipped a detector default from false to true. The key line is where the error hides. Ignore repeated bigrams changes how observed count is computed, whether repeated token bigrams get counted once or every time they occur. That changes the z-score, that changes the p-value, that changes the detection verdict for any text that sits near z-threshold of 4, 0. A commit labeled documentation updates change the detection statistic. The verdict, the algorithm is honest. The mechanism is 282 lines and it does exactly what the paper says. But the mismatch between what the README recommends and what the tree imports is a real gap, and the commit that said documentation updates changed the scoring rule. If you audit a text and the detector says no, you are reading a p-value above 4, 0, not a ruling. The watermark is statistical, so is the doubt. Your turn, take this into your own session. Clone JW Kirchenbauer/LM watermarking, open watermark processor. Pi and ask Claude what happens to detection power when you raise delta from 2, 0 to 5, 0 and what the model quality trade-off looks like at high delta. Then ask what z-threshold controls and what a false positive looks like at 200 tokens with no watermark present. Liam, in for bear. The watermark is one line of code.